And welcome everyone to the safety and performance benefits of autothrottles for turboprop airplanes. I'm Matt Thurber, Editor-in-Chief of Aviation International News, and today we're going to discuss how innovative solutions and support turboprop autothrottles system not only greatly lowers pilot workload, but also adds significant safety benefits, especially for twin-engine turboprops. Joining us today are Tom Grunbeck, Director of Autothrottle Programs at Innovative Solutions and Support, and Aaron Tobias, an FAA consultant and designated engineering representative, flight test pilot. Now, we welcome all your questions, and all you have to do is just type them in the webinar question field, and we'll get to them towards the end of the webinar. AIN would like to thank Innovative Solutions and Support for sponsoring today's webinar. We're going to start out first with a poll to see whether webinar participants are using autothrottles, and then after that, later on, we'll have a second question about what you think about autothrottles. So first, have you ever flown with an autothrottle? And so far, it's looking like pretty much 50-50. I have flown with autothrottles, and I much prefer to have them, especially in a complex airplane flying in busy airspace. Now we're trending more towards the no side. We'll give it a few more seconds here, see what it comes out to. That's good. We're looking at about 63% no, 37% yes, which is good because we're all going to learn more about autothrottles and their benefits today.
You bet. Just a brief introduction. My name is Aaron Tobias. I've been had the pleasure of working in aircraft design and flight testing for about 20 years, supporting new aircraft, derivative aircraft certification, development, and in recent years, had the opportunity to work on developing autothrottle systems and supporting the certification activity for turboprop aircraft. And so it's a pleasure to get to visit with you folks today. Hope to be able to answer your questions and talking about the great new capabilities that are up on the market today.
Okay, Tom, go ahead. You've got the floor now. Thank you.
Okay, great. Thank you very much. We all know that there are three axes of an airplane: pitch, roll, and yaw, and that's controlled by the autopilot. Today, we're discussing the fourth axis, power and airspeed, and that's controlled by the autothrottle. The areas that we're going to be going through are the flight path, including safety, power management, installation, economics, and technical attributes. One takeaway to come back from this presentation is today is about the full regime autothrottle, engaged for takeoff, climb, cruise, descent, landing phases of flight, including go around. The full regime autothrottle from takeoff to landing phases of flight, including go around, includes enhancement of safety operations, envelope protection, including speed limit and VMCA protection, reduced crew workload, increased situational awareness, and stabilized approaches. Significant reductions in cabin noise due to smooth changes in engine power and strict adherence to speed targets. FADEC-like engine protection that reduces engine exceedances for torque and temperature. The system that we're specifically talking about today is the King Air, and the total installed weight is less than 5 pounds. There is MEL relief and able to dispatch the airplane if ATS, if the autothrottle is inoperative. We have maintenance on condition. The reliability, we have a 60,000 cycle, highly accelerated life testing has been completed. The system improves reliability and operating costs through the engine limit protection, currently operating on Eclipse 550, PC-12, and also the King Air. When is the best time to install? Usually on the King Airs during phase 1 or phase 3. with any other avionics installations. There's a 2-year warranty on the system, and the Autothrottle is fully integrated. Some of the benefits from an owner and economic standpoint are smoother transitions into each flight mode, asymptotic approach into speed targets with no overshoot, engine exceedance increases dispatch reliability, reduces downtime, and greatly reduces maintenance expenses. The return on investment mostly is from the engine protection, limiting extensive or increased inspections on the engine, since we're protecting against over torques and over temps when the autothrottle is engaged. Also, the rule of thumb for fuel savings on autothrottles that's accepted by the industry is 3%. And we have extensive operational safety features. This is a high value system. This is the first time the autothrottle is available for turboprops, and other autothrottle retrofit systems have been over $200,000. The selling price for the King Air ProLine 21 cockpit is $67,500. What the system comes with when you order it is a complete installation kit, including all components, wire harnesses, brackets, with pre-drilled pilot holes, clips, hardware, and fasteners. The system, the kit is so complete that it's field team capable as well. All wiring during the installation is in the cockpit area of the airplane. There's less than 8 days of downtime, and the system is currently certified on the PC-12 Legacy, NG, King Air B200, and King Air B300. Okay, Aaron.
Yeah, thanks, Tob. So let's talk a little bit about what you get with that installation and why you might want to do that for your aircraft. So folks have been operating autothrottle controlled jets for decades, and obviously the capabilities that are provided with workload reduction, speed control, stabilized approach, performance capabilities are all things that have been frankly out of reach for turboprop aircraft with mechanical flight controls. But the capability of an add-on system that this type of technology brings to the market really allows for flight crews to take advantage of many of those same things without really driving up the cost or complexity of their cockpit significantly. So as Tom mentioned, the capability exists, let's get it out in the forefront there, that if you put the system in your airplane and you still want to fly it manually, you just do. There's nothing special you have to do. You just don't turn it on. If in the event that you had any kind of malfunction of the system, it's not going to slow you down either. It is fully capable of being of operating dispatch without the system functional. So a lot of great things on the backstops there, but as you mentioned, it's a full regime in the context of the autothrottle is used from takeoff to right before touchdown, and just kind of walking through a flight profile. At least if you want to jump to the basic flight profile page there, is pretty simple, what everybody knows of, but just kind of walk around the cockpit here and talk through each of these stages of the flight profile and help you guys get a sense of understanding as to how you would utilize a system such as this in your airplane. So if we jump down to the cockpit illustration, in the B300 with the Fusion cockpit layout, you will see in the blow up image there, kind of the primary pilot interface to the autothrottle, of course, is it replaces the standby flight display unit, top and center in the cockpit. And on that control is the power button to engage it, menu button to make a variety of selections, and of course, because it replaces the standby flight display, that's part of where some of the cost and weight benefits or a lack of increase in weight comes from. It's replacing otherwise required equipment in the aircraft with the system. So you have barrel controls and other simple functions, navigation, etc. And then the knob in the bottom right corner is where the fairly simple pilot interface all comes together. The other thing that is part of the cockpit installation is down on the throttle quadrant. So the auto throttle, first and foremost, only controls the throttles. It does not control props or condition levers or anything else. And I'll talk about a little bit later on how that is actually beneficial. But on the throttle levers, it utilizes the go around button so that the system is tracking with the with what phase of flight's going on. So if you, for instance, you're on an approach, you press the go around button, it's going to transition the auto throttle automatically to a go around phase of flight. On the opposite throttle knob, whereas on the King Air was previously nothing there, they've added a corresponding button, which is a disengage button to the for the auto throttle. So walking through a simple flight profile for normal operations, you're going to line up short of the runway, and all you're going to do is reach up there and hit that AT power button. The system is smart enough to know what the current state of your anti-ice systems, your bleeds, switches are, and it's going to provide you on the screen what its predicted static takeoff torque value needs to be for that day, given the temperature. You roll out on the runway and you press another button, and the throttles will automatically smoothly bring the throttles up to target that static torque value. Now, it's still the pilot's responsibility to verify that the system indeed achieves book numbers for your takeoff performance, but nonetheless, the automation is there to help ensure that the throttles are hitting those values and maintaining them. And where this is really becomes beneficial on the takeoff roll in two key ways that I've found is, number one, the power applications are nice, slow and smooth operations, similar to what you would do or experience in a jet aircraft. And the rate of throttle advancement allows for really softening some of the sharp pitch changes in sound that your passengers often might point out as to indication that they're flying in a turboprop. The other key benefit is you are ensuring that you are getting book takeoff torque. As Tom mentioned, one of the factors associated with flying a mechanical controlled turboprop is, of course, possibility of exceedances. And so you're protecting your engine in the sense that you've got the automation of the electronic controls keeping you away from over temp or over torque. But on the other side of that coin, you've also got the automation ensuring that you are achieving book takeoff power on each takeoff. So where many operators might just stand the throttles up part way and take off with less than full book takeoff torque, this system, when engaged, will provide for that on each takeoff. From there, during a normal flight profile, you're going to transition through climb and utilize either torque or speed mode controls. We can talk more about those as questions come later, but nonetheless, those are the two primary functions throughout the phase of flight that provide a host of protection, envelope protection capabilities, all the way through the normal flight profiles, all the way down to breaking out at minimums. A couple hundred feet above the ground, you would press the button on the right throttle knob to disengage and then manually land the aircraft as per normal. So that's just a quick run around for kind of a normal flight profile. And I'll stop there because I know we'll have plenty of other opportunities to unpack some of those concepts.
Thank you very much, Aaron. So, Tom, is it kind of like you're getting the benefits of a FADEC, full authority digital engine control, without actually having that on the engines?
Well, actually, this auto throttle system not only controls speed and power, but also protects the engine from torque limits and also temperature limits. It also has speed limits within the system. So you can fly a full regime flight path and not have any issues with exceeding temperature or torque throughout the whole flight path. So based on what your question was, Matt, it's FADEC-like functionality in that it protects you from exceeding any of the engine limits and also speed limits of the airplane.
So, and it does that. I mean, you can use this right away on takeoff, right? There's no limitation on when you can switch it on, right?
Now, you actually line up with the center line, you engage the system, and the system will go right up to takeoff power for that density altitude for that day, based on the pilot's operating hand guide. We'll go up to that torque and also protect the engine from any surges that may occur. So it'll automatically correct for that. What you as a pilot will do then is concentrate on staying down the center line of the runway, and then obviously pulling back and taking off based on that speed. And then 5 minutes after takeoff, it will go into cruise mode. And then from there, you go into cruise mode, and you can select speed mode, or you can select torque mode. If you select torque mode, it will fly the fastest speed for that altitude. And if you select speed mode, it will stay within that at that speed throughout your cruise. And it's the same as descent and also stabilizing approach through landing phases of flight. Now, if you have to go around, you engage the auto throttle in the go around button and go into go around mode, and we'll go up to takeoff power, and it will go around. So it's a fully functioning system from takeoff to landing phases of flight, including go around. Truly, it can be used as a hands-off system. Now, if you want to override the system at any time, you just put your hands on the throttles just as you would your manual control, and just push it forward or push it back, and the system will disengage, and then you can hand fly the airplane from there.
So
Well,
basically, sorry, go ahead, Aaron.
Yeah, I might interject on your question about takeoff. That's, one of my favorite things about it is folks that know that when you're flying a King Air after takeoff, it's kind of a 3-knob operation. You get your gear up, you're climbing out, everything's looking good. Now it's time to pull your props back to climb RPM. And I say, it's a three knob operation, in that you got to pull the torque back before you can grab the prop levers, pull them back to bring the noise down and get you to climb RPM. And then you reach over and you push the throttles back up to hit your target climb torque value. Well, when you're using the auto throttle for that phase of flight, it's simply grab the prop levers and start pulling them back to the climb RPM. And the auto throttle is going to recognize the increase in torque that's happening just based on the physics of the props moving, and it's going to automatically adjust the throttles back to hit the target torque value that you've got set in from the controller. So that is in the apart from looking up your takeoff performance numbers, that is the first thing that in-flight folks will recognize as an immediate workload reduction in an otherwise busy phase of flight.
And so if you're getting to an altitude where temperature's the limitation, it's going to automatically prevent you from over temping too, right? Yeah,
absolutely. So the auto throttle, depending on the airplane it's installed in, of course, knows what engines are installed, and it will respect the appropriate AFM recommended climb or cruise temperature limits. So that crossover point, as you're in the climb out, that you used to have to kind of keep an eye out for, just keep pushing your throttles up to to keep your power on, the system's going to do that automatically for you, and then it's going to respect the more restrictive limit.
Okay. So for people who aren't really familiar with flying with auto throttles, can you, Aaron, just summarize kind of how much safer and smoother it is to fly with them? Maybe you can go back to when you first experienced one.
You bet. So I'd venture to say that hopefully most folks are operating or have operated with an autopilot, and so there's certainly a philosophical mindset shift when you transition to first time operating an airplane with an autopilot. Now all we've done is we've moved it into the fourth axis with the throttles, and much like an autopilot, it's going to do pretty much exactly what you tell it to. Now, where the real benefits that you will find once you get comfortable essentially trusting the system, as you have learned to trust your autopilot, with fairly limited training, actually, is pretty easy to learn. As I tried to lay out on the outset, the controls are fairly simple. But once you've dialed in your torque or speed targets, it's just going to go there, and then all you've got to worry about doing is taking care of the rest of the business in the cockpit in terms of monitoring the autopilot or briefing your approach plates or what have you. And the things that it does even beyond the autopilot, for instance, if you do and find yourself distracted and you've asked for a descent and you've commanded a low torque setting, and then the airplane levels off, the autopilot levels off at some altitude, and really what needs to happen at that point is an increase in power in order to maintain your speed. In the event that you are distracted otherwise and your speed continues to slow, the auto throttle is going to recognize that you are approaching a margin to a stall speed, and it's going to actually automatically increase the thrust to make sure that you don't decelerate below that speed. And then to further continue on that train of thought, if you then put yourself in a turn, it's going to recognize that your margin to stall is decreased because you're turning, and the load factor associated with it. It's going to automatically increase the now commanded speed to keep you at a safe flying speed until you have a chance to return your attention to where it should have been in the first place. But it's going to help keep you out of trouble in those areas. So where one of the highest workload aspects of, for instance, flying approach is marrying the combination of pitch and power. And when you've been able to tell the system to drive to a set airspeed, all you do is put the nose where it needs to go to follow the glide path, and it's going to fly that airspeed. And you don't have to worry about if you catch a gust and you end up a little low and you pitch up to recenter the needle. You don't have to worry about your speed bleeding off, because the auto throttle is going to take care of you. It takes a little getting used to, because again, you got to develop a trust in the system. But in short order, I think folks will find it is quite delightful.
So the auto throttle is available for the single engine PC-12 also, and I assume a lot of the benefits are similar in terms of helping you manage power and speed, especially in a busy approach, right?
Yes, that's correct. For the PC-12 and the PC-12NG, it gives you the same engine protection for torque limits and temperature limits, and also can be engaged for takeoff roll, and also protects the engine against any engine surge on takeoff. We actually have an operator up in Canada that regularly flies his PC-12 with the auto throttle up around the Arctic Circle into a very narrow gravel runway. And what the advantages of the auto throttle for him is he can line up with the center line of his gravel runway, and it's very short. engage the auto throttle, come up to max torque, he can concentrate on steering the airplane down the center of the runway, then lift off at the least amount of speed he needs in order to take off. So it gives him a great advantage and really increases the safety of his operations. But it's available for the PC-12 Legacy and also the PC-12 NG. And the installation is the same as was discussed with the King Air. What we're doing is replacing a standby unit that's currently in the airplane with the IS&S integrated standby unit, which also houses the Autothrottle computer in it.
And Tom, this system that we're looking at on the Proline Fusion, would that be the same one that's going to be in the new King Air 360?
Yes, that is the installation in the King Air 360. So as you can see, that's the IS&S integrated standby unit. It also has a remote unit that goes up into the doghouse on the glare shield, and then gets integrated into the Fusion cockpit.
And then, Tom, can you talk a little bit about what's unique about the IS&S autothrottle technology, because it's different from traditional autothrottles, isn't it?
It operates the same way. It operates just as if, you know, in the most advanced business jets, but it also has a feature on it that exists in no other airplanes. It has dynamic VMCA protection against loss of control of the airplane. This is a separate STC system that's integrated into the standby unit computer. So if an aircraft's engine fails and the aircraft's airspeed falls below its minimum control speed, VMCA, the aircraft can experience a loss of control. However, aircraft equipped with a thrust sense system can dynamically adjust the power, and the key word here is dynamically adjust the power in the remaining engine to assist the crew in maintaining safe control of the aircraft. Years ago, I was an engineer on the F-14 program. We had VMCA protection on the F-14, but that system, it came back to a fixed 25% power on the good engine. What our system does, it dynamically adjusts the engine power, and it computes the amount of rudder authority lost due to the reduction of airflow over the rudder, and executes the necessary reduction in thrust from the remaining engines to prevent the loss of control when airspeed drops below VMCA, maintaining safe control of the aircraft. What IS&S has done with the thrust sense system has made it optimized for retrofit, where we're replacing an existing instrument in the airplane and replacing it with ours. The other, obviously, the key issue that goes into the airplane are the actuators that control the power levers. And what this system does, it moves the power levers just as if the pilot would move. So it does operate just as well as, or just as most advanced business jets, with the addition of dynamic MCA protection for the airplane.
Thank you, Tom. That's an interesting feature. So, Aaron, can you talk a little bit about the test flying that you did for the VMCA mitigation?
You bet. So obviously, I think everybody flies multi-engine airplanes knows that you should never take an airplane that's lost an engine, critical engine to boot, below the blue line speed. And unfortunately, it happens time and time again in the high workload environment of a takeoff or go around scenario that folks that just aren't rated for it have that unexpected, untimely engine malfunction. And so what, as Tom was getting at, what we did to demonstrate the system for the certification is take it out and set it up for a simulated takeoff scenario. Of course, just at a couple of thousand feet though. Do a fuel cut on the left engine, critical engine for the King Air, and then slow the airplane down all the way till stall warning. when that happens, as it was referred to as a dynamic adjustment of the right-hand engine, when that happens, the right thrust is the throttle is reduced proportional to the speed decrease below the respective model's VMCA speed as you decelerate. Now obviously, if you lost the engine immediately after takeoff and you got slow and you're banking on your V2 climb speed to get out of there, and you've already decelerated below V2, below VMCA, and the throttle's coming back, you're not climbing. So you aren't, there's no guarantee of performance, but at least you're still flying, provided you maintain clear of obstructions to allow you to get the nose back down to where it needs to be to get you back to a climbing speed. So once you lower the nose back towards and then above the VMCA speed, the throttle on the operative engine, the right throttle in my example, will slowly increase all the way back up to assure that you have maximum power for the conditions of the day. And then all you've got to do as a pilot is make sure that you've got full rudder in and aileron appropriate to the condition, and put your nose where it needs to be in order to get to your V2 target. So it really takes that. There's about a 5 to 10 second window of criticality when you're talking about an engine failure on a takeoff or a go around, where you're low to the ground, you're slow airspeed, a low energy state. And it really provides crews with that extra 5 to 10 seconds worth of, call it error margin, if you will. So where they may have had enough altitude to tolerate a loss of climb, they don't have enough altitude to tolerate a loss of control because they allowed their airspeed to bleed below VMCA. So it's pretty interesting capability. Not something that's comfortable to test in real life, but fortunately I believe flight safety textron aviation training's got the system in their simulator now, and folks can go out and see what that is like in the simulator safely, and not worry about doing full power fuel cuts on your engines, which is never great for engine lifing.
Right. I think that simulators at the Tampa Flight Safety True Training Center. Right, Tom?
That's correct, and it's fully operational at this time.
Okay, so this is, I mean, if you buy this system, do you strongly recommend going down there to get some simulator training?
Yes, and Aaron, just go through what the training requirements you see for the system when you buy the airplane.
Yeah, so essentially if you're Part 135 operator, required to comply with the FSB type rating differences requirement. So the FSB report should be coming out shortly, and it's essentially a self-study of the AFM, the pilot's guide, and then about an hour, give or take, of ground training, briefing, and review of those materials. And then really in less than an hour of actual flight or simulator time, the pilot can become proficient to be able to launch out on his own with the system. Like I said, the crew interface controls are pretty simple, and it's really once you understand the what's going on kind of behind the curtain and how those simple control interfaces affect the modes, then you'll be ready to roll.
And Tom, IS&S has also done demos of the system. In fact, I was lucky enough to experience one myself, and we did the VMCA mitigation demo. But can you maybe go through a little bit how you can demonstrate it in the airplane itself?
Yeah, we do demonstrate it based on the customer's approval of the person getting the getting the demo and so forth. But I also like to highlight that we're having 2 demo days at the Indianapolis Textron Service Center Center, November 17th and 18th. So if anybody wants to come out and demo the system, ISNS will have their airplane. It's a B200 GT, fully equipped, obviously, with the Autothrottle system, and you'd be able to fly that airplane yourself.
Okay, and let's go ahead and go to our second poll question, and we're going to ask, what do you see as the most important benefits of an autothrottle? And we'll take about a minute for those answers to come in. And after that, we'll take some of the attendees' questions. So far, it looks like safety is definitely a strong consideration, especially for the multi-engine applications. Lower workload is an important one, but not the highest. Same with more efficient engine operation. Yep, safety is still coming out on top, especially if you add the two middle questions. Okay, let's see what those results look like. And definitely appreciation for the multi-engine benefits, 37%. Lower workload, helping with safety is also important, and lower workload during busy flying periods. Efficient engine operation is definitely a benefit, but not seen as the highest one. Thank you very much. And let's go ahead and look at some of the questions. And one of the questions we have is, how does the auto throttle react during throttle up if the ground idle solenoids are not quite rigged to go off at the same 70% NG? Does auto throttle engage after the 70% NG switches are made during the takeoff roll?
I think it's the easy answer to that is that they're unrelated. The auto throttle is simply driving the throttle levers to a target torque value, and once it achieves that target torque value, or temperature, I should say, if it reaches a temperature limit first, then it's going to control to that value. So obviously, you have to expect that the airplane is rigged according to the maintenance manual requirements. So trying to answer what happens if it's not can kind of be a slippery slope, but there is no interaction electrically or otherwise between those systems.
Okay, thank you, Aaron. And here's another question. How does the system integrate with stock propeller sync and auto feather systems, or does it supersede them?
So I think it's a similar answer to the previous question, actually, in that the auto throttle is not tied in any way to either of those systems, prop sync or auto feather. There, a limitation does exist, just as frankly a technicality, in the sense that if, for instance, the auto feather system fails, then you're required to disengage the auto throttle in the event of loss of an engine. But that's only because you can't test the system for dynamic engine failure if the system isn't doing what it's supposed to. So you're in an abnormal scenario there, and the basis on which the power reduction for the operating engine in that circumstance would not be known for a windmilling engine.
Great, thank you, Aaron. So Tom, here's a question. Is the ISNS system collecting any data or generating any data that could be helpful for the operator or, for the engine manufacturer to see? Like, could it be appended into the flight data recorder sets for a FOQA flight operations quality assurance system?
Well, yeah, we'll collect some data within the computer that always can be downloaded. I don't know the interaction or the interface with the FDR is, but it's not a it's not a tattletale system for the pilot, and so we don't aggressively sell that feature that is collecting the data.
Great. Thank you, Tom. So in terms of integration with the Fusion avionics flight deck, in regards to the question is, what kind of integration with the Fusion system in regards to engine display and VNAV descend speed limits?
I think that the only place that you'll find that integrated per se is that the speed that you are selecting for the auto throttle to command to, if you are in speed mode, that speed selection is the same speed selection as in the mode control panel on the Collins autopilot mode controller. So otherwise, the auto throttle is reading the same data that's going into the MFD as far as engine indications, and it's using it to control, but it's not sending any data. So integration is, from that standpoint, really one way. And that really helps. That really helps, by the way, with making it as much a standalone system as possible, so that you're not introducing new variables that would prevent dispatch in the event of an issue with it.
Great. Thank you, Aaron. So here's a question asking, what is supposed to be the most important benefit of an auto throttle? And is it really supposed to be a substitute for pilot emergency procedures proficiency? And I would, based on my experience, I'd say it supplements the pilot's proficiency, but let's see what our experts have to say.
Well, actually, when auto throttles first came into being back in the 50s, it was auto throttles came on the scene to stabilize the approach on landing. At that time, that was a very important characteristic, and it still is today. But in the early 70s, actually, there was an L-1011 that flew on Eastern Airlines that flew from Palmdale to Dulles Airport in Washington, D.C., and it was slated as the first fully automated flight. And that was made possible by a full regime auto throttle system that was on that airplane. And since then, many of the most advanced airplanes do have auto throttles for the full operation of the flight path. This is the first time, though, that an auto throttle system is possible and has been made available for the King Air. It is a full regime system. It protects your engines because your engines are not FADAC like some of the most advanced business jets. And it also has this BMCA protection. So actually today, this feature-rich thrust end system for the King Air gives you many different safety benefits and operational benefits that will really pay dividends for the pilot and the operator of the airplane.
Yeah, Matt, my thought on that is really with the reliability of today's engines, an engine failure, particularly in a critical phase of flight, is something that very few people will ever experience. And so it's hard to say that that is the number one benefit of it, because it's really it's just life insurance that's kind of hanging out there. You hope you never use, but really the day-to-day benefit in it is with the smoothness of operation and reduced pilot workload. And so your passengers and you are going to notice that the things that drive up workload are making sure that you're not over temping, over torquing. You're able to get maximum performance, recommended book performance in each of your flights, and you do that with the ability to really just enjoy the flight operation, not worry about getting oversaturated task load wise. And out of that is where the safety benefits in the day-to-day operations over the life of the aircraft are going to come from, while you've got that insurance policy, so to speak. It's kind of hanging out in the background for that rare event.
So clearly the pilot's still in the loop, but has some extra help in the rare case where it might be needed.
Yeah, absolutely. It's like Tom said, whether it's stabilizing an approach or providing a smooth transition during, you find yourself in a busy environment, or a noisy cabin with distractions, whatever your situation might be, and anything that you can do to just shave off one more layer of saturation is going to drive up the smoothness of the operation, and ultimately get you to your destination safely.
Great, thank you, Aaron. So Tom, we have a question about the PC-12NG take rate and installation cost.
Well, actually, the kit for the PC-12 is $54,000, and it's a complete installation kit that's sold to the PC-12 fleet. There are several PC-12 NGs currently flying with our system on it, and the pilots have noticed terrific reliability with the system. Not one, there hasn't been any instances that the actuator or the system hasn't operated, and that's over several years. And that take rate is increasing every day, just like the King Air. As a new product introduction over the last several years, the acceleration of sales is moving forward as people within this aviation sector realize and appreciate the capabilities of what a true autothrottle system is on their airplane.
And Tom, in the same vein, we have a question about whether this might be available for King Airs with the Garmin G1000 avionics suites.
Yes, we're saying in the second quarter of 2021, we'll be doing that system. Right now, we're doing the, we have the King Air B200 Proline 21. We have the B300 Fusion. The B300 Proline 21 is being certified this month, and then we're going to be doing the King Air 250 Fusion. And then from there, we'll eventually be doing the C90s and also additional cockpits that are available out in the field.
Excellent. And here's a question about the safety benefits. Are there perhaps opportunities for insurance rate improvements with this kind of system installed?
That's being discussed with several different insurance companies right now. And once we get the contact list, we'll be able to reapply with that once we get a determination from the insurance company.
Great. So we have a technical question regarding maintenance of the system. where are the auto throttle actuators actually located? Would that be in the quadrant?
Yeah, it's actually in the pedestal. It's directly below where the power levers are, and the actuators are directly in line with the power levers and the teleflex cable that goes out to the engines. You can access it through the side panels of the pedestal. And just to say again, there is MEL relief for the system, so you can still dispatch the airplane if the autothrottle is inoperative. And the system is also on condition maintenance, which means there's no scheduled maintenance for this system.
Great. And Aaron, here's a question. On go around, does a pilot need to reach up and select the new torque limit on the standby unit?
No, that's a great question. No, with the press of the go around button on the throttle, as he should normally do for sequencing the autopilot to flight director modes, the auto throttle, provided it was already engaged during the approach phase, is going to automatically transition from the speed or the torque mode that he was flying up until that point in time, and it's going to automatically bring the throttles up to go around power per the AFM.
Okay, thank you. Good question. And what about when the auto throttle disconnects, either by the pilot commanding it or a system malfunction? Is there a visual and or oral alert?
Good question. So yes and yes. So if you can jump back to the cockpit, you know what, I think that cockpit picture has the blow up on top of the annunciator. Yeah, unfortunately, right behind the blown up view of the standby display, it's right on top of the PFD. There is an additional cube light that's a green annunciator that advises that the auto throttle is engaged. And then if you're looking at the standby control unit there that is blown up, the top right corner has the AT power button. Immediately above it is an LED that is either green or amber to indicate engaged or disengaged. With the disengage, you will also get a oral chime or a voice that will say auto throttle, and that is dependent upon which avionics platform that the installation is in.
Very good. Glad we got that question. Tom, what happens to the auto throttles if the system is inoperative? In other words, are the frictions removed from the actuators?
No, actually, with a little additional increase in force, it's very minor. You just move the power levers just as if you would move them normally. And so the airplane flies very similar to a non-auto throttle equipped airplane without the auto throttles working.
And I assume you could override them just by manually pushing the power levers anytime, right?
Yeah, absolutely.
Yeah, that's correct. It's a couple of pounds of, I call it running resistance that's there all the time, whether the system is turned on or not. And that really does a nice job of taking the place of the old friction locks that are still there, but you turn them all the way loose when you install the system. And then when the auto throttle is engaged, if circumstances warrant, you get a TCAS RA or something, and you want to push the power up to effect an escape maneuver from a wind shear or something, and you don't have to worry about disconnecting. You just grab the levers and push, and it's about 10 pounds of force, give or take, to override the system while it's still engaged until you can get your finger on the disconnect button.
Very good. Tom, a question for you. Any STC planned for the King Air F90?
Yeah, I've gotten that question numerous times. And we're taking a look at that to see what the similarities between that airplane is and also the B200. But that's a favorite airplane of mine. It's just a great looking fast airplane. And we sure would love to get the autothrottle on that airplane.
Excellent. So we have one last, two more questions I think we can get through here. Is there a magnetometer input available for the ISU so you could get independent heading information on that?
Yeah, if you jump back to the cockpit illustration there, I'm not sure if it's yeah. So it's already there, and it's displayed across the bottom as a kind of a rolling drum display. And there's several other manufacturers in the industry that provide standby flight displays with a similar presentation of heading on a rolling drum there. What's not depicted there is, in addition to your basic air data and attitude and heading information there, through the menu selections, as I mentioned earlier, you can turn on navigation, short range nav and DME presentation there. So you can get VOR, ILS, glide slope, DME, etc.
Okay. And then, Aaron, are there any additional pre-flight or pre-takeoff system tests or check?
Yeah, good question. It's pretty simple. Make sure that the friction locks are all the way off, and you turn the system on, and if it doesn't flag any faults, then you're good to go.
And speaking of friction locks, we had a question. Do the actuators compensate or eliminate throttle migration?
Yeah, so there is, like I mentioned previously, there is a running resistance from the actuators that, in my experience, holds the throttles pretty much wherever you put them, similar to how you would set your friction locks to hold throttle position in the prior to system installed state.
Excellent. And then last question, is the heading information that the ISU gets from an existing AHRS or from a separate magnetometer?
Tom, I'm not sure I think that may be installation specific. So I'm not sure there's a cut and dry answer to that.
Yeah, right. Well, what we're doing is just replacing the standby unit that's currently in the airplane. We have a remote unit that feeds the display. So the operation of that is a direct replacement for what's already in the, what would have been in the airplane to begin with. And our system just has the addition of the autothrottle capability and control of it.
Great. Well, we're actually over our time now, and we've gotten a lot of excellent response from everybody. Great questions. Tom and Aaron, thank you very much, and we appreciate everybody participating today, and also ISNS's generous sponsorship. This webinar was recorded, and we will share the recording with all the participants on tomorrow after it's ready. And if we didn't get to your question, we will follow up directly with a response. Thank you very much, and thank you for your patience, and have a great day.